In this video, we're going to be talking about this Modular Arithmetic Part 3 word problem right here. Involves using divisibility tricks, and it's one of the harder problems in this Modular Arithmetic unit, Part 3. A group of monsters landed on Earth and started splitting in two every hour. For any positive integer k, we use n sub k to denote the number of monsters k hours after landing. We know that n sub 0 is less than 5, fewer than 5 monsters landed, and that the two digits at the right end of n sub 100 are 28. How many monsters originally landed? So we're looking for the number of monsters that landed on Earth and then started splitting to get, after 100 hours, 28 monsters. So that leaves us, or not 28 monsters, but the two digits to the right of 100 hours, the number of monsters is 28. So we have 5 choices for the number of original monsters, because it says here that fewer than 5 monsters landed. Or 4 choices, really, because we can't have 0. Because 0 monsters, nothing would ever split. It would just be 0, 0, 0. So we have 4 choices, 1, 2, 3, and 4, for the number of monsters that landed on Earth. So as you can see here, the number of monsters n sub 100 here, it ends in 28. And we have a divisibility rule for 4. The last 2 digits of the number must be divisible by 4. And in this case, 28 is a multiple of 4, which means that our number here, n sub 100, is divisible by 4. So that means that after 100 hours, the number of monsters must be a multiple of 4, because we know this, the divisibility rule. So we can just make this fact here divisible by 4. And then from there, we basically test what would happen if there are 4, 3, 2, or 1 monsters. Kind of stretch the pattern out, see if you can find any patterns in the numbers. And then look at the last digit. The last digit is always very important for this kind of stuff. To try to find out if if after 100 hours there are going to be a number of monsters that's divisible by, multiple of 4. So when we start with 4 monsters here, we just start writing out some, after a certain amount of hours, how many monsters there's going to be. Pretty simple here. 4, 8, just double it each time. 4, 8, 16, 32, 64, 128, 246, 512. So we have a few numbers here now, and we can check and see if there's a pattern. So as always, we're going to look at the last digit. We've got 4, 8. We're just going to ignore the first one, actually, because that's going to set everything off. We don't want to look at this. Starting here at the 8, we've got last digits of 8, 6, 2, 4. 8, 6, 2, 4. Just going to repeat. The pattern for 4 monsters is 8, 6, 2, 4 for the last digit. I'm going to write this down right here. 8, 6, 2, 4 is the last digit. So if we know that after 100 hours, the last digit is going to be 8, or the last 2 digits are going to be 2, 8, then we know if this continually repeats, then on 100, this must be 8. Otherwise, it's not 4 monsters. So this is, we're going to call this 1. This is 5. This is going to be 8. The next 8. So there's going to be an 8 every 4 numbers, every 4 iterations of this, basically. So to find out, or 3, I should say, to find out whether this is true, we can divide 100, which is the number of hours after they landed, by 3 to find out if the last digit is really going to be 8 here. So we can test if 100 is divisible by 3 by summing the digits. If the sum of the digits is divisible by 3, the number itself is divisible by 3. So 1 plus 0 is 1, and 1 is not a multiple of 3, so this does not work. Since 8's going to be some other hour, it's going to be like, 99 or 101 or something, but it's not going to be 100. So we know that there are not 4 monsters. That's not what's going on here. So we progress to the next one, which is 3 monsters that landed on Earth, starting at 6. This one's a bit tricky to find the pattern, actually. So we have 6, 2, 4, 8, 4, 2, 6, 8. It's a bit weird here. It doesn't seem like it's actually a pattern. 6, 2, 4, 8, 4, 2, 6. It's kind of weird. So instead, what you have to do here is look at where the 8 appears. Got an 8 right here after 1, 2, 3, 4 terms. 1, 2, 3, 4 terms later, another 8. And this pattern will keep going all the way through. So we know here that there's going to be an 8 every 4 terms. And so from there, what we could do is we could find out, well, is 100 a multiple of 4? And that's easy to find out because the last two digits of 100 is 0, 0. That means that 100 is indeed a multiple of 4. And what this then tells us is that after 100 hours, the last digit of the number of monsters is going to be 8. And that pretty much gives us our answer right there, because the last two digits are 2, 8. There's not another number that's going to be in this pattern that has a last digit of 8, but that has some other previous digit. So that's why we know it has to be 3 monsters, because it's 8 here, we tested it. 100 is a multiple of 4. So thus we know there are 3 monsters that originally landed. And that's how we solve this Modular Arithmetic Part 3 word problem here concerning monsters.